Hi friends, so in this video, we're going to solve the palindrome number problem from the Leetcode. So this problem is kind of, I would say, a little bit tricky because it involves some edge cases. But overall, this is a good problem to solve. So I decided to solve this problem. So let's go through it and try to understand what this problem basically asks. So we have been given integer x, and we need to check if this integer is palindromic or not. So if you're not familiar with what palindrome means, so it's basically that it reads same from the front as it reads from the back. So if you have 1 to 1, then if you read from the back, it's again 1 to 1, right? So this kind of structure is called palindrome. Even in the case of string, you have something like, let's say, race car. So if you read from the back, it reads same, right? So this is the basic concept of palindrome. So that's what we are doing here, but we are playing with the integer over here. So if we have like 1 to 1, it reads same from front and back. So that's what we have to check. So we have been given input x, and then we need to find out if we reverse it, then that reverse number and then the given number are equal or not. So it's that simple, but working on this reversal part might be a little bit tricky. So let's first understand how we can do it. And if we go towards so for the example, it gives us a good idea. So 1 to 1 is palindrome. That's why we are returning true. We have minus 1 to 1. So if we return it, because of this negative sign, it won't be palindrome. So this gives us hint that as soon as we get the negative number, we can easily say that's not palindrome, because we won't be able to keep the position of negative at the start, right? So that's the thing here. So if we have like minus 1 to 1, it will become 1 to 1 minus. So whenever we have the negative number, we are sure that it's not going to be palindromic. So we can return false immediately. Then we have the number like 10. So once we reverse it, we have this 0 and 1. 0 1 basically reads as a 1, and then these are two not equal. So we can say that these are not palindromic. One of the trickiest part here is that the constraint. So we have this x, which is 2 raised to 31 minus 1. So this is like a max and min of integer. So since we are dealing with integer, this is the max value. And the problem with this is going to be like when you have the max value, and once you try to reverse it, you will end up in the integer overflow problem. I will discuss about it later once we go through the code, but that's one of the tricky thing we will face in this code. And then there's also one of the follow-ups is that can you do it without converting integer to string? So basically it gives you a hint that it can be done within string, right? Basically. So yeah, let's try to solve this problem, and first of all on the whiteboard, and then try to code it. So we have let's say 1 to 1, right? So what we gonna do is that we need to reverse this number. So how do we reverse it? So basically, if you know, there is a mod operation, right? So when you do the mod operation, it basically returns the remainder. So if we have like 1 to 1 and we do the mod 10, then the number that is going to return is 1, right? So it's going to be basically returning the remainder of the after dividing it, whatever is the remainder, it will going to return it, right? So that's one going to return. And we also do the division on this. So when we divide it, we get the next digit. So we have already deal with the first digit, and we found out the remainder is 1, and then we also divide the number so that we can operate on each number one by one. So this is the for the first digit, right? And now when we go to the second digit on the backward side, now our input is 12. So now we again mod it, and here our remainder will be 2, and then again we divide this number by 10, so it gives us the 1. This is the next number that we will be dealing with. Now once we have 1, we do the mod 10, and this will return 1, and then again we divide 1 by 10, and then we get a 0 over here. So this is where we stop, right? So we need to see that when our number becomes 0, and we basically stop our iteration. But this is how we do it, right? So first, this is where we calculate the digit number 1, 2, and 3. And once we have this 3 digit with us, we can basically merge them back and see if this input is equal to reverse. So this is the first digit. So we have 1, we merge 2, and we merge 1. So now I'm clicking over here all these digits as a string. So when you concatenate string, you get the final string as 1 to 1, and basically you parse it, and you get the from string you get an integer, and now you can easily compare, right, this number with your input number, and if that is equal, we basically say that yes, our input is palindromic. Now again, negative part is easy, right? We don't have to do any operation. Since it's negative, we know that is going to be false. So we can return false here. Let's deal with 1, 2, 3, which is kind of not a palindromic, right? So we cover both the cases when it's palindrome and when not. So in the first iteration for the digit 1, what will happen? So we'll have 1, 2, 3 mod 10, that will give us 3, and 1, 2, 3 divided by 10 will give us 12. Similarly, for digit 2, we'll have 12 mod 10, that will give us 2, and 12 will be divided by 10, so that we get the next number to work upon. That will be our 1. And for the digit 3, we have 1 mod 10, that gives us 1, and we have 1 divided by 10, that gives us 0. And since it's 0, we can stop our iteration. And now we have all the digits with us. So D1, D2, and D3. If we concatenate them, we have 3, 2, and 1. So all the mods that we did, if you concatenate them, we'll get the 3 to 1 as a string. We can pass them to integer, and then we get the output. So this is how we I'm sorry about. Okay, so this is how we can pass this number, and yeah, but in one of the thing that is mentioned in the question is that we need to do it without converting the integer to string, right? So how can we achieve that? So one of the thing is that if whenever we do the mod, we know that we are having the mod operation, and then we are getting the digit at the each position of our output. So if we consider this final output, we see that we have a 3 over here as the first location, then we have a 2, and then we have the 1. Okay, so if you see position of 3 is having, like, if you see the position, the first position has 10 raised to 0. So what I'm saying here is that we have 3 into 100 plus 2 into 10 plus 1 into 1. So if you see, this one is basically 10 to the power 0. This 10 is 10 to the power 1. And this is basically 10 to the power 2. So that's how we give the positional values, right? So for 3 has a positional value of 100, 2 has a positional value of 1, and then 1 has a positional value. If we try to understand this flow, we can construct these integer as we move forward. So when we calculate 3, we also multiply immediately in the next iteration with 10, and the remaining value we then multiply by 10, and so on. So as we getting the integer, we keep multiply by 10. So that how we will be able to build our string with the positional value. With the integer, with a string, it was very simple, right? We just concatenate and then parse it. But here we trying to use this positional value and then trying to build that number with that logic of the position. So let's try to dive into the code and try to understand how we can build it. Okay, so we have, first of all, we have this integer given to us, right? And one of the edge cases, we found out that whenever the number is negative, we can return the false. So let's get that out of the way. But if when we have the positive number, we can construct it. So first of all, I would like to take a copy of x, since we will be modifying our x, so we don't want to accidentally change the x value because we need to eventually compare it, right? So we are taking the copy of it. Once we have the copy of it, we also want to have the reverse integer. Let's give a 0 value here. We will be constructing it as we traverse through our input value. So we will check if our copy of x is not equal to 0. Since this is the string, this is the integer where we will be on which we will be working upon, right? So what we're gonna do is we're gonna take the mod as we explained in the whiteboard. So we do this mod operation. We also have a reversed, so we need to add this value to our reversed. And we also have to, as I said, we need to multiply by 10 for the positional value. So as we move forward, we multiply by the positional values here, right? So in the first iteration, when the value is 1 to 1, in the first iteration, our mod is 1, and our reverse value at that time would be 0. So 0 multiplied by 10 will be 0, and then copy of mod, copy of x and mod 10 will give us 1. So it will be coming out to be 0 plus 1 as a reversed value. That will basically be 1, right? Now, when you go to the next iteration, you have 12 mod 10. That would give you 2. And this 2 will be part of this copy mod 2, right? And then you have this reversed into 10. So in previously, we calculated the reverse as 1, right? So in reverse would be 1 into 10 plus this 2 will be added to it. So we will have 12 here. So we have constructed this integer, right? And then again, when we add the last integer, that is 1 mod 10 would give us again 1, and we'll do this calculation of reverse into 10, right? So reverse was how much? 12. So this 12 would be multiplied by 10, and then we add the mod to it. So this will again construct back to 1 to 1. This is how we are basically building our positional value. We keep multiplying the digit by 10 as we move forward in the iteration and build the positional values and finally construct the reverse integer. So this is how we are doing. We can construct the reverse integer. And once we have this reverse integer constructed, what all we have to do is that return and we compare the integer with reversed. If this is true, we basically get the true. If it's not true, we get the false. So if we try to execute this, we'll get the so the first, okay, I'm having some compilation issue, cannot find symbol copy of, okay, I think I missed it here. All right, let's try again. Oops. Okay, so I made a mistake here. I also explained in my whiteboarding that we have to, divide this by 10 each time so that we keep reducing our numbers and as we move forward, right? So whenever we read like first digit, we go and then we remove that first digit from the next iteration. So we have to do this as well. So it works here. Let's try to run all the test cases and see we pass it or not. And we are. So let's try to submit this and see if we get the answer for this one. And yeah, it gets passed. But I would like to touch upon about the last value, as I said. So we are treating with integer, right? So max value of integer is this value, 2147386, okay, pick number. So when you have this as a test case, it will give a right answer, but it's accidentally right. So let me give you the print line here, and let's print the reverse. So ideally, what is the expectation is that the input is 214, the output should be 7463, right? I just wanted to touch upon here that this is accidentally correct, but it's not exactly, it's not actually correct. So if you see, this value is overflowed value because when you start with 7, it's more than the integer value. So basically you you cannot have value more than this number, right? 21474837. So this is the max value that you have on the positive side of the integer. But when you start with 7, you reverse it, you will have more than value higher than the max value of integer. That's why basically overflows and gives us the negative number. And since it gives the negative number, it kind of works for us. And this x equal to reverse basically returns false. That's why it gives us the right answer. But yeah, but when we work with the string, you would probably get the exact, the reversal of it, and then you will be comparing it, and then you can get the false answer there as well. So yeah, I think that's what I wanted to cover in this problem. This is the palindrome number question. Uh, Gives the good idea of how to build logic on the numbers, how to iterate on the digits, how to get the each digit from the number through the mod, and how we can construct the integer back. So I think that's it. I will see you in the next one. Thank you so much.